Okay, today we're going to play detective and dive into a really fascinating biological mystery. We're talking about a bacterium that's a secret stowaway inside the stomachs of about half of all humans on the entire planet. But here's the real puzzle. For most of us, it does absolutely nothing. But for a handful of people, it causes some serious problems. So let's get our investigation started. First off, you have to appreciate just how incredibly common this bacterium, Helicobacter pylori, actually is. And the first thing you'll notice is this massive difference depending on where you live. In developing nations, you can see infection rates as high as 80%, often by the time people are just 20 years old. In industrialized countries, it's lower, more like 30 to 50%, but come on, that's still billions of people walking around with this bug. But, and this is the first major clue in our case, even with billions of people infected, only about 10 to 15% of them will ever actually develop an ulcer. The huge majority of people will live their entire lives with it and be completely unaware. So, this is it. This is the central question we are here to solve today. It's a fantastic biological detective story, you know? It's got a super clever pathogen, a really powerful immune system, and a twist you might not see coming. All right, to solve this mystery, we first have to understand our main suspect. How on earth does this tiny little organism manage to survive in one of the most hostile environments you can imagine? I mean, the human stomach. That acid is strong enough to dissolve metal, and yet H. pylori calls it home. How? So let's meet our microscopic stowaway. It's an S-shaped gram-negative bacterium. And you see those little tails? Those are its flagella. They're basically tiny propellers. Now, a really key point here is that it doesn't actually invade our cells. Instead, it's specifically designed to live in that protective mucus layer, just sticking to the surface of our stomach lining. Its strategy for survival is, frankly, genius. It's a two-step plan. First, it uses those flagella we just talked about to literally drill its way through the stomach acid and burrow deep down into the thick mucus lining, where it's a lot less acidic. But that's only step one. Step two is its secret weapon, its superpower, really. It produces a massive amount of an enzyme called urease. This urea grabs urea, which is just floating around in your stomach anyway, and turns it into ammonia. And since ammonia is alkaline, it neutralizes the stomach acid all around the bacterium. It creates this little personal acid-proof force field. It's incredible. Okay, so we've established it's an absolute master of survival. But just surviving doesn't cause problems. So how does it actually do harm? Let's take a look at the weapons in its arsenal. So here are its tools of the trade. First up, you've got this thing called CAGA. It gets injected right into our stomach cells, almost like a microscopic syringe, and that causes injury and kicks off inflammation. Then there's VAT-K, a toxin that basically pokes holes in our cells. It also has these things called adhesins, which are like super glue to help it stick to the stomach lining, and proteases, which are enzymes that literally chew up and break down our protective mucus barrier, leaving the stomach wall totally exposed. And now, folks, here comes the plot twist. The bacterium and all its weapons, that's only one part of the story. A huge amount of the damage is actually a team effort. The body's own immune system, trying to fight off the infection, actually makes everything much, much worse. Your body, of course, does not just sit back and ignore this invasion. No way. It sends in the cavalry, a whole army of immune cells. We're talking neutrophils, T and B lymphocytes, macrophages, the whole shebang. It mounts a full-blown inflammatory response right where the infection is. So here's the absolute crucial point. This is what you need to get. It becomes a two-front war. On one side, you've got the bacteria attacking with its toxins, but on the other side, you've got the body's super powerful counterattack. The problem is, this immune response can't ever really get rid of the infection, so it just keeps fighting and fighting, creating this constant, low-level chronic inflammation that just grinds away at the stomach lining for years, sometimes decades. So let's review. We've profiled our suspect, we've examined its weapons, and now we understand the collateral damage from the fight. We have all the clues. We are now ready to solve this central mystery. Why do only some people get sick? And the answer, the big reveal, comes down to one single critical factor: location. It's all about where in the stomach H. pylori decides to set up camp. So get this, if the infection is mostly in the antrum, the lower part of the stomach, it messes with the body's hormone signals and actually causes the stomach to pump out more acid. This extra acid then spills into the duodenum and causes duodenal ulcers. But
If the infection is mainly in the corpus, the main body of the stomach, that chronic inflammation actually leads to atrophy. It destroys the acid-producing cells. This means less acid, but it also creates a weaker stomach wall, and that's what's linked to gastric ulcers and a higher risk of stomach cancer. It's amazing, right? Two totally different outcomes.
So, there you have it. Case cracked. Let's pull all our clues together for one final verdict on this incredibly complicated relationship. If you only remember one single thing from all of this, let it be this idea right here. The final outcome isn't just about the bug, and it isn't just about the person. It's all about the complex, decades-long dance between how nasty the bacteria is and how the host's body decides to respond. So let's just quickly recap the case file. How does it survive? That urease enzyme is its acid-proof shield. How does it cause damage? It's got a whole toolkit of weapons like CAG-A and VAC-A. What's the main source of the injury, though? It's the body's own endless inflammation. And what's the final decider on what disease you get? It all comes down to the location, location, location.
And that brings us to one final, really thought-provoking question. You know, H. pylori has been living with humans for thousands and thousands of years. But now, with better sanitation and antibiotics, it's actually starting to disappear from a lot of the world. And while that's obviously great for ulcer and cancer rates, some scientists are starting to wonder, what happens when we remove an ancient member of our gut microbiome? Could there be unforeseen consequences? What's the next chapter in our gut health story? Well, that's a mystery for another day.